أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. So we are back with the chromatography. We have some basic terms remaining. So आज हम first of all will start with the a term called as the retention time. Fine. तो retention time के लिए straight forward एक easy approach जो मैंने बोला था कि just make a column. Imagine that in the chromatography you have a column that's packed with the stationary phase. Back to the stationary phase. Fine. And then, now this is packed with some stationary phase. Then we'll pour some solvent over it. This is your mobile phase. It can be liquid, gas, and usually liquid. So that's your mobile phase, and then this is your the column packed with the stationary phase. Now we have the concept of the retention time here. Retention time. So the concept of retention time. Now what do you mean by the retention time? Now अब इस सैंपल ये जो कॉलम है now we'll pour our sample. Fine. Now we know that this sample, this will undergo interaction between the preferential, I should say the either distribution or partition between mobile phase and stationary phase. So it will go distribution between mobile phase and stationary phase. So there will be a continuous equilibrium existing. Let us say this is your mobile phase and this is your stationary phase. The solvent at this, as the solvent is flowing, fine. So there will be the partition between mobile phase and stationary phase. जो ऊपर से mobile phase आ रहा है and the stationary phase, दोनों के दरमियान the chemical species, the analyte will distribute itself, so it will partition itself. So we assume that there is equilibrium existing at each and every point. Okay? Now, let us say after 30 minutes, now the analyte comes out. The chemical species comes out. So, as we have seen that we'll get a graph. It's like this. So you have the signal response. That signal response versus the time. So you'll get a graph like, now this is the peak, so you're getting it up to this much time. So let us say this is t is equal to 0, this is t is equal to 5, this t is equal to 10, let us say the scale is in the minutes. So that after 10 minutes, you are getting good peak height, that means the light comes out. So this time, the amount of time this analyte has taken to come out of the column. So from that time period when we injected the sample, that time t is equal to 0. So this was the point t is equal to 0. So this time taken by the sample to come out, or analyte to come out of the column, to get detected, and then we'll get a good peak. So this is called as the retention time. Fine. So this is denoted by TR. So this is the time taken by the analyte to come out of the column, to get ejected from the column and get detected by the detector. Now there is one more time, this is called as dead time. Now there's one more term, this is called as dead time. Dead time. So what dead time actually means? So what actually this dead time means? Now we'll do one thing. When we have poured the mobile phase over it and we have poured our sample also, let us assume that the sample has almost 100% interaction with the mobile phase and almost negligible interaction with the stationary phase. इसका मतलब ये हो गया, हम ये assume करते हैं कि इसका जो है, ये जो chemical species है, entity है, या sample है जिसको हमको separate करना है, let us say they were two analytes. इनकी जो इंट्रैक्शन है मोबाइल फेज के साथ ऑलमोस्ट 100% है and there's negligible interaction with the column packing or the column material, that means it will get quickly come out. ठीक, उसको हम बोलते हैं फ्लशिंग आउट. So इस कंडीशन में the time taken by the a component, yeah, it is the illusion time of that particular component to come out of the column. अब since ये material आप it will not stick to the column because हम assume करते हैं कि इसकी interaction is almost 100% with the mobile phase, तो हम उसको ऐसे कह सकते हैं it is basically the illusion time. It is simply the time taken by analyte to come out through the once the solvent flows. So it's the illusion time of unretained component. So your dead time is basically the illusion time. It is simply the illusion time. Illusion time. क्योंकि solvent elute हो रहा है, ये तो it has 100% retained the solvent. So it's the illusion time of unretained component. So it's the illusion time of unretained component. इसको हम illusion time क्यों कहते हैं? Because it basically comes out directly with the solvent. It's unretained component. It has no interaction with the stationary phase. ठीक? So it is simply the time. It's simply the time required to flush the column. Let the element to pass through the column. It will come out. It will come straight forward. So this time is called as dead time. Fine. So this dead time is designated by T0. तो हमारे पास दो terms आ गई. So we have two terms. One is the retention time and one is the dead time. So we have two terms, retention time and dead time. So retention time and dead time. डेड टाइम हमने कहा कि जब केमिकल स्पीसी की जो है इंट्रैक्शन विद द कॉलम इज नेग्लिजिबल, इट इज होली एंड सोली इट्स ऑलमोस्ट 100% गेटिंग इनसाइड द मोबाइल फेज. सो इट विल स्ट्रेट फॉरवर्ड. जब तक आप ऊपर सिर्फ सॉल्वेंट डालोगे इट विल कम आउट ऑफ द solvent. So it's some sort of flushing the column. So that's called dead time. Retention time is now यहाँ पे इसकी interaction है both with the mobile phase and stationary phase. So the amount of time analyte will come out of the column in this condition, that's called the retention time. Now these two quantities are very important. For example, we'll discuss a term called as a capacity factor. Capacity factor. Capacity factor. Capacity factor chromatography में we designate by K, that is basically equivalent to, that is your retention time minus the dead time divided by the dead time. So the retention time, obviously your retention time is more because now the analyte has interaction both with the stationary phase and mobile phase. It will take a lot of time for this analyte to come out. Minus the T0, it will be very less. जितना time solvent लेगा column में pass होने में, that will be the retention time. So that will be the dead time. Retention time is dead time divided by the dead time. So this is called as a capacity factor in the column chromatography. So this is called as the capacity factor of the column chromatography. ये जो capacity factor है, it is independent of the column geometry. Column geometry. So it has nothing to do with the column geometry. Number one. So it has nothing to do with the column geometry. And then second thing is that it is so the capacity factor is a measure of retention of a phase, is independent of column geometry, and it is independent of the flow rate of solvent. It is independent of flow rate of the solvent. तो capacity factor से basically हमें क्या पता चलता है, as it is the difference between the retention time and the dead time. So we are basically in a position to measure the retention. So it's a measure of the retention of a particular peak or a particular analyte. So this is the capacity factor. Then, so it's a capacity factor. Now we have one more term that's called as a selectivity factor. So this is capacity factor. One more term called as a selectivity factor. Selectivity factor. This is one more term used in the chromatography, that is the selectivity factor. Now let us say हमारे पास जो sample है, it has two analytes. Let us say we have a sample. It has two analytes, 1 and 2. ठीक? So हमने ये sample को pour किया over the column. There's a it's packed with a stationary phase, and then we are also, meanwhile, हमारा mobile phase, we were allowing the mobile phase to flow through it. Fine. Now let us see the chromatograph. The instrument will give us the graph like this is our signal. Let us say it is the conductivity, response conductivity, and this is the time scale in minutes, retention time. So we'll get the peaks like this. Two analytes. This is peak 1 for analyte, another 2. अब ये भी हो सकता है कि sometimes the peaks will come very close. ये भी हो सकता है कि sometimes the peaks will come far away. ठीक? So if the situation is like this, the peaks are really close. Situation can be like this. The situations are, the peaks are far away from here. Look at the difference. So the peaks are far away. In this case, the peaks are very closer. They're almost very close to the overlap here. Now, if the peaks are very overlapped, closer, that means it's difficult to distinguish the analytes. The analytes have very close interaction between with the mobile phase and the stationary phase. In this case, this has a different type of interaction. This is different interaction. This is possible since for this peak the time period is more, so its interaction with the stationary phase is more, its interaction with the stationary phase is less, or vice versa, its interaction with the mobile phase is more, its interaction with the mobile phase is less. Now in this case, the peaks are getting separated easily. We'll get one peak, and then after 20 minutes, 30 minutes, another peak, another light. But in this case, they are very close interactions. So in this case, it is very difficult. The sample which you will get, there it will be having both the components present. यहाँ से जो analyte आ जाएगी वो दोनों at a time, दोनों आ जाएंगे at a time. तो separation efficient नहीं होगी. इस केस में separation efficient होगी. तो selectivity factor basically हम लोग use करते हैं selectivity factor. It is used to define the. So we can define this as the selectivity factor is used. So we can write down selectivity factor is used to define the ability or the power and the capability of a chromatographic system, ability of a chromatographic system to distinguish, to make difference, to distinguish the sample components are chemical species in a sample, two chemical species, components. So basically selectivity factor gives us the capability. Now if the selectivity factor is 1, and selectivity factor is denoted by alpha, it is usually the ratio of, let us say this is the K, that is the capacity factor for the peak 2, or for the component 2, the component 1. Now if it is 1, that means their interaction, they are very closer. Now if this value is 1, that means the peaks are coming together at the same time. So I should say the peaks are co-eluting if the value is 1, co-eluting. Elution means coming out of the column, from the column. When the solvent comes out, it's called elution, or when analyte comes out from the column, elution. Co-eluting means they will come together because the K values are closer. So the capacity, selectivity factor is 1. That means they are co-eluting. Fine. Now, so this is very important that if the difference becomes major, then you can easily distinguish the two peaks. It is very easily to separate for that particular chromatographic system the chemical species. So selectivity factor is basically used to define the ability of a chromatographic system to distinguish the two chemical components. So it's the ratio of the K factors, that's the capacity factors of each analyte, and if it is 1, that means both are co-eluting at the same time. तो ये तो होगी some basic terms, dead time, the retention time, the capacity factor and selectivity factor. So this is, I believe you understood. If you not understood, so please write down on this mail, MEKANDCHEM@gmail. So you can write down at gmail.com. Please write down. I'll be in a position to answer you back. Hope you understood. So this is all for the day.